Hello, everyone, and welcome to Office Hours, a program where we invite luminaries from the software world to share insights. These are one-on-one sessions with experts, and they've been a huge success. I'm Lauren Demuse, partner and COO at Theory Ventures, and I'm delighted to introduce our discussion today. To begin, Tom Tungus is the general partner at Theory Ventures, our $230 million fund focused on companies leveraging technical discontinuities into go-to-market advantages. Prior to founding Theory, Tom spent 14 years at Redpoint as a general partner, where he made investments like Looker, Mother Duck, Monte Carlo, and Omni. We're joined by Baris Gultekin, product lead for AI and ML at Snowflake. Previously, Baris spent over a decade at Google across various product leadership roles, including running Google Assistant and working closely with Sridhar. He's been at the cutting edge of enterprise AI for decades at some of the most influential enterprises in the space. Today, we have the chance to probe these experiences more deeply and get into how AI will impact the modern data stack. With that, I'll hand it over to Tom and Baris.
Baris, welcome to Office Hours. Thanks so much for joining us. Great to see you. We used to work together a lifetime ago at Google, and you've gone on to have this phenomenal career now. We were the head of AI at Snowflake. Can you just catch me up here? What led you to take the leap to join Snowflake to run AI strategy? How did that come to be?
First, thanks for having me. It's great to talk to you. It's been a while. I joined Snowflake about a year ago through an acquisition. I had a startup called NXYZ, and Snowflake acquired our company, and I came in, and now I run the AI and ML efforts at Snowflake. And it's interesting from a career perspective. I was at Google for a long time, and I ran the Google Assistant product team on mobile.
Love that product. Use it every day.
It was interesting because the world has changed so much in the last 2-3 years, transitioning from a time when AI did not quite work. And now we have amazing LLMs that are accessible to everyone, and changing the world. So it's awesome to be, what a time to be alive.
Yeah. You've seen those two waves, right? So what do you, like, AI didn't quite, it worked for individual use cases, right? I think about like Assistant, I can ask it for the weather, I can ask it for a stock price. Yeah, and now all of a sudden, you have this new advance, right? And you're clearly a part of it. How do you think, what does that mean in the world of Snowflake? You guys have clearly been pretty active here in the world of AI. We could talk about a bunch of the individual announcements. But what does it mean for Snow?
At Snowflake, companies trust Snowflake with their crown jewels, their data. And what we've been working on is how do we bring the world's best AI capabilities onto where the data is. And the moment we do that, everything becomes a lot easier and trusted, and that's been our focus. So our customers, with their data on Snowflake, can now run large language models, can build chatbots, can run all sorts of interesting analysis across their data. LLMs bring amazing capabilities to get most out of their data.
And that's what you call Cortex. That's the Cortex product. It's a suite of AI building blocks on top of, I have all my data within the core relational database, super high performance, separation of compute and storage, the story that created the multi-decacorn here. And then on top of it, there's this Cortex product that you're building where I can take my existing data. And I wanted to share with you, we've started to use actually a new feature that I'm not sure when you released it, but ingestion of PowerPoints and PDF documents into. Yes. And it's amazing because we were playing around with it yesterday, and literally with a single example, effectively one shot, we were able to get pretty good accuracy coming out of the product.
That's right. Yeah, exactly. Cortex is that product. Essentially, it allows our customers to just use prompts and then run all sorts of interesting analysis across their data.
But the thing that I've noticed the most about you, and particularly since you've taken this role, is just the pace. Yeah. It seems, I don't know, every week, every other week, every month, there's a pretty meaningful push. The most recent one was just this morning where I think Snowflake has announced that you're working with Llama 3.1, and I was just looking at those benchmarks, pretty spectacular. Walk us through, what are some of those key innovations, and how are you able to keep up that pace?
Yeah, we've been definitely hard at work. All of the AI world has been. The world is changing so rapidly. I talk to a lot of our friends, and everyone is working incredibly hard. So we're no exception. We have been we've been very lucky to bring some of the world's best experts in AI, both from a training perspective as well as inference perspective. Some of the early creators of VLLM, for instance, are now at Snowflake. DeepSpeed are now at Snowflake. And this team has built our own language model, Arctic. And most recently, today, we launched support for Llama's large model. Llama 3.1 405B, and we've optimized it so that it's running a lot more efficiently. And we're also making these optimizations available open source so that anyone that's using VLLM can benefit from it and run these super large language models.
That's awesome. And so VLLM, that's a virtualization layer. So you can imagine if you're running a model, you can basically maximize the performance on a particular machine because you're parallelizing or running other kinds of optimization, right? Yes. It's amazing that's amazing that you're giving it to the ecosystem open source. And is the vision then with Cortex, you have Arctic, as you mentioned, you've been partnering with, Snowflake's been partnering with NVIDIA, now you're partnering with Meta, with Llama. Is the vision then to basically offer a suite of different models to customers depending on what their use case might be?
Yeah, so at the core of it, Cortex is our managed service that provides access to a series of large language models from Meta, from Mistral, Reka, NVIDIA, and others, including our own language model. The goal here is to make it incredibly easy to use various large language models with the data that our customers have on Snowflake. And then on top of that, we've built higher level products so that our customers can build chatbots really easily. We have a search product that enables it. We have a Cortex Analyst product that allows our customers to build structured data analysis so that you could run BI type questions and then get answers directly from natural language to SQL to answers. And all of those are done with the goal of running everything inside the Snowflake security boundary so that it's all secure, trusted, as well as super easy to use.
That makes sense. So touching on Arctic for a second, when is the right time for a customer to use Arctic compared to another model?
Yeah, so we've built Arctic with the goal of focusing on what we're calling enterprise intelligence. And the way we've defined enterprise intelligence is for Snowflake customers, it means we need to do really well on SQL, given that Snowflake is bread and butter is SQL. Instruction following is really important. As you do various enterprise tasks, complex instructions become important. So we wanted the model to do really well on complex instructions, as well as general coding skills with Python and others. So that's the core set of benchmarks that we optimize the model. And this model is now available, and both from us as well as from our partners, and our customers are using it. They're using it mostly for kind of text to SQL type queries, but it also does really well in, as I said, instruction following. And some of our international customers are also finding a lot of value in its international performance.
Oh, fantastic. So one thing that we haven't historically, or I haven't historically thought about Snowflake is open source, right? And Arctic is open source. Polaris, I think, will be right. Open source. And you mentioned the contributions of VLLM associated with running the massive model coming out of Meta as being open source. Let's talk about that. Like, why the change, and how do you think about AI and open source? What's going on in that world that has led Snowflake to take that strategic evolution and direction?
Yeah, let me start with the AI part, and then I can expand more broadly as well. On the AI side, so first of all, we've benefited tremendously from, as I said, VLLM and DeepSpeed, both are open source projects. And the contributors of these projects are now at Snowflake, and we've benefited a lot from the open source community, so we wanted to contribute back. We also believe that we can move the science forward by putting it all out there. Recently, Llama and Meta has been pushing the envelope on open source, and it's been great with the model weights being open source. But we wanted to go a step further, and we shared our learnings, our cookbooks, so what we call cookbooks, how we achieved the benchmarks with a relatively small budget, for instance. We made all of these open source as well, along with our data recipes. Overall, making AI more accessible and also more open is good for business as well. Our customers really appreciate openness. They want to understand what kind of data goes into these models so that they feel more confident to use it. So overall, it just made business sense as well, in addition to being able to contribute back to the community. And then more broadly, increasingly, we are embracing open source with Iceberg and Polaris catalog as well. The goal here is we don't want to lock our customers into a particular platform. We want to offer choice. And instead, we want to win these customers by being the best to do something versus just locking into proprietary systems.
Yeah, it makes a lot of sense. And it seems like the emphasis has really picked up there. And it seems like the advances that you've made, you mentioned it briefly, but your ability, Arctic, I think, was trained on significantly less costs on a relative basis compared to other models. And you mentioned this a little bit. What are some of the core innovations that allowed you to do that? How does that work?
Yeah, the big innovation was on the model architecture itself. So normally these days you have a mixture of experts models or fully advanced models. Our architecture for Arctic is a combination of the two. So we have both the dense part of the model as well as a mixture of experts. And we've used many experts in the system. When we combine this architecture with the right training recipe, like first teaching the model the basics and then teaching the model in more advanced content, we were able to train the model with about 1/8 the cost it takes similar benchmarks, similar models to train. So it's very efficient both from a training perspective, and because we're using a lot of experts, the number of active parameters is relatively small. So even though the model is large, the inference cost of the model is also very small. So it's efficient both for training as well as for inference.
Yeah, it makes a ton of sense. And that ties on, inference cost is a really big deal, right? A lot of customers, I think, or a lot of users are starting to see some of these bills, and that is driven. We have these mega models, like the one we were just talking about today, right? This 400 billion parameter model coming out of Facebook. But then you also have this raft and this next generation of smaller, the SLMs, right? And I'm curious, like, how do you see, across the ecosystem, when do people use large language models with Snowflake? When do people use smaller models? And how do you, because of these inference costs, right?
Yeah, so we're seeing that a lot of our customers start with the large model for proof of concept, so that you first want to see if you can achieve a certain task with the best model that's out there. But the more you get closer to production, of course, you start optimizing it, either fine-tuning, distilling it to a smaller model, or just using a small model with a more optimized set of prompts. And this strategy works. Today, for instance, when you look at the Llama 3.1, the 8 billion parameter model, it is a tiny model, but an incredibly capable model. Yeah. So more and more, we're seeing that being able to distill smaller models from these large models works and then creates very efficient, relatively cost-effective LLMs. And that's what we're doing.
Yeah, it makes a lot of sense. My mental model for it has been these really large, the mega models. They're basically compressed representations of a big search index that is really sparse. And then what we're able to do is like a principal component analysis. Is not exactly the right terminology. It's basically some kind of real compression on it. And like you said, the Llama model, I've been playing around with Llama 3, 8 billion on my, not 3.1, but 3 on my machine. And the performance it's really incredible. And I'm doing it on consumer grade hardware. And so we're also seeing in the world of startups that people start with the very, very large language models because they want to be able to address any number of particular use cases coming in. And then as the use cases crystallize, then they decide, okay, I'm going to use this particular SLM for this particular application, this SLM for another application.
Yeah, exactly. Saves time to start with the large one without having to worry about optimization. But then, of course, you want
root of all evil, right? Isn't there that computer science aphorism? So within the world of startups, now we've had this world of copilots, text-to-SQL, auto-completion. One of the big things, at least within the startup world, and I'm sure what you're seeing in Snowflake, are these agentic systems, right? Where you have multiple steps and the robot is working on making a plan, deciding what to do, calling different models. Sometimes you have an actor and a critic, and they're increasingly complex architectures for building some of these workflows. How do you think about Snowflake's role within the world of agentic systems?
So it's an exciting time to be observing that shift from just using a single model to having these systems capable enough to be able to reason and then call multiple tools and then do some things with it. We have a product, I alluded to it, Cortex Analyst, which is a pretty sophisticated product in that it's supposed to answer business user-facing questions. So normally you have all these complicated questions like, how is my revenue changing week over week in this region for this product and so forth. Being able to convert that, first of all, understand that you could answer this question, figure out how to generate the SQL for that question, running that SQL, making sure that SQL is correct. And all of these components are steps that need to be done by this orchestration system. And now these agentic systems are able to handle it and then increase the quality of the system substantially. The way I see Snowflake's role here is, of course, we use agentic systems ourselves, as I've said, with things like Cortex Analyst, but we're also seeing more and more our customers are starting to use these agentic systems. If you think of Snowflake's role, Snowflake is the trusted data cloud. So I'll give you an example from the finance industry. You have ecosystem data providers, the likes of FactSet and S&P, for instance, that have trusted Snowflake with their data. Now, all of that data can be leveraged in other parts of the financial application system. So having easy access from an agentic point of view to all of these systems becomes really critical, so that anyone that's building a financial application, for instance, now has easy access to all these financial agents to their orchestration system. So I see Snowflake's role as both the place where kind of the core data lies, but also this data now becomes AI ready, and agentic systems can now take advantage of all this data and the agents that are on the platform.
Yeah, the security model I think is what's key, right? I think if you think about over the last 18 months, we've been interviewing different kinds of data leaders and security leaders and engineering leaders, and there's a data risk, right? That like one of the key parts of any data security infrastructure is data loss, preventing data loss. And data leaders have been thrust into this position now where the board and the CEO, and I'm guilty of this as any other board member, we need an AI strategy, and we need it now. And the challenge for many of these leaders is we really need a security system in place so that the systems are working the way that they're intended to. And so what I'm hearing you say is the vision for Snowflake is, since the data already exists within the cloud, let's bring these tools, these models into a particular place so that within this ecosystem, you can do whatever you want, and then you can push it with a lot of confidence into production.
Basically, customers bring their data, and then they govern that data, they manage the access controls of that data, and they have their ecosystem partners that also bring their data. And now, when you bring AI to the system, everything can run in the same security boundary, and all of the access controls can be governed and respected. Today, as more and more companies go from POCs to production, governance becomes a really important aspect, security becomes a really important aspect, and Snowflake, by virtue of having the data, being the data platform, can provide all of this functionality at the core of the platform versus something that's bolt onto it afterwards, which then makes it super difficult.
Yeah, that makes sense. And so if I'm building with Cortex with a large language model and I have my data inside of Snowflake, how does the access control layer work between those two parts of the stack?
Yeah, with Cortex, first of all, all of the access controls that you've put on the data are automatically respected. So we focus a lot on kind of trust at the core of our system. So granular access controls can be at various levels, column level, row level, and so forth. And all of that is respected by the LLM when you ask a question. On top of that, you can govern your LLMs directly as well. So if you imagine you build a fine-tuned model for HR, and then you want only HR to be able to use it. The system allows you to say only HR can use this model, and then the specific person in HR can only have access to the specific data on Snowflake. So both of those combined become a really powerful offering for enterprises.
Makes sense. Yeah, that's awesome. That's cool. Then you have a lot of confidence that you're doing things the right way, right? As long as you're within the ecosystem. Let's talk a little bit about embedded applications. I've been a huge fan of embedded applications. I've worked with a lot of them. There's a bunch of advantages to actually building software companies on top of Snowflake. And the way to think about it is, because you're on top of Snowflake, the sales cycle is faster. Don't have to go through a procurement, security, all that kind of stuff. The second, and the data is already in exactly the right place. The second is the overall gross margins for the software company are actually higher because the customer's effectively paying for the core infrastructure within their Snowflake account. And then the third is you have a great partner in terms of Snowflake who is aligned in getting your application actually driving workloads and driving benefit for customers. Can we talk a little bit about how that's evolved? Is that still a key priority for Snowflake?
Please.
And then how does that interface with AI? Is there an overlap there that you're seeing today? Is it still early days? How do you see it going into the future?
Yeah, we see ourselves as a platform company, and we have a healthy ecosystem of our partners that build applications on top of Snowflake. And then this is a great partnership. Our partners, as you said, can bring these awesome applications onto Snowflake. Our customers can benefit by trusting that this data is using, the data isn't moving, so it's secure, it's governed, but still they get the benefit of bringing compute next to the data. With AI, the same strategy still holds. We have the likes of Landing.ai, Kumo AI, really capable, awesome applications that are building on Snowflake so that Snowflake customers can use these great products directly.
That makes sense. And the other thing that you touched on that I would love to talk a little bit more is data sharing, right? If I think about like the story at the IPO, the Salesforce investment, if we talking to different customers, the data sharing component of a financial institution wanting to share information with, say, a marketing partner has been a core of what's going on with Snowflake. The Samuha acquisition, a big part of that. Can we talk about data sharing inside of Snowflake and what that means for the business? Is that about extending the ecosystem and making sure that the security perimeter continues to be strong?
One of the biggest challenges we used to have is, I'll actually start with the consumer world. We used to email PowerPoints and Excel spreadsheets back and forth, and then version them with all sorts of different versioning names. And then at some point you said, no, we can just keep it in one place on the cloud and then have pointers to it so that it can be shared. Now, the same thing can be done with massive amounts of data, which is much harder to move anyway. Now, being able to say, okay, so I'm going to allow you access to this, I'm going to govern this access, makes it super compelling for both multiple companies sharing data with each other, as well as for large organizations to share data entered within the company. So this is a very important part of our data cloud strategy, and we pay close attention to kind of how we're fostering that ecosystem, because as more companies share their data, that data becomes a lot more valuable and a lot more easy to access. With AI, that becomes even more important because data feeds AI, and now not only do you have access to the data, but you can glean even more insights more easily from the data. So data sharing is core to AI as well.
And it's core both on the training and the inference side, right? So what I have to imagine is there are companies that will develop or fine-tune their own models. Maybe they'll do it on Snowflake. And so they'll want access to different kinds of data. Maybe somebody's preparing some kind of a credit risk analysis score, and they want weather, and they want geolocation data, they want credit purchasing history. And so some of that data might be first-party data that they own. Some of that data might be third-party that they're able to get through Snowflake data sharing. And then they might train their own model. And I'm curious to hear, what role do you think Snowflake has on the inference side, and what role does Snowflake have on the training side? And does that change with time?
And it's not just inference and training. There's also now more and more products are being built around all of these. So like we have a search product, for instance, like that makes data sharing super interesting. So you have a massive amounts of data, and then you can add a search layer in front of it, so that a customer of yours can come and directly query that data and then make use of it in a way that they weren't able to before. So the way we see ourselves is we make inference incredibly easy to use. So it's super easy to fine-tune models in Snowflake. We have the serverless way to do this, as well as functions to do that. Inference is incredibly easy, no setup necessary, no pipelines necessary, because the data is already there. We make it very easy for our customers to do both. But then on top of that, as I said, we bring these text-to-SQL as well as search components to the data so that you can essentially make that data talk to any AI system or any application directly.
That makes sense. Do you find within the world of Snowflake, is there a lot of data reshaping that's required for AI workloads, either on the inference or the training side, to be useful?
There's a lot of data reshaping that happens on Snowflake, of course. For training, depending on what you're doing, whether you're doing pre-training or fine-tuning, there is a lot of data work necessary to prepare the data. For inference, the beauty of these models are you can just describe what you want to do, and then you can extract a lot of super interesting information from them. Extracting information from large amounts of unstructured text becomes super easy. It's fascinating how powerful these things are.
It's incredible. I think we think a lot about them as they're generative and they can create and they can summarize. They're also phenomenal classifiers, right? To your point, like you can take a bunch of qualitative feedback from an HR survey or what have you, and then ask it, what is this about, or what's the sentiment of it, and we do this internally. When a company sends us a pitch deck, we go through it and we classify it into, is this a machine learning company, is this a software company, is this a data company? And it works, which is, it's hugely surprising, but as a classifier, it works really well. And so this means that you can work with structured and unstructured data, right? That's the implication. I can take structured data coming out of Snowflake, I can combine it with, or also unstructured data inside or outside of Snowflake, and actually generate some value from it.
Mm-hmm. Yeah, exactly.
If you think about the fraction of structured versus unstructured data coming into some of these machine learning models, do you have a sense? Is it 50-50, 60-40, 75-25?
In terms of usage?
In terms of usage, yeah.
We're seeing both structured data use cases where I want to enable business users to ask questions. They would normally have to go through analysts. And now can we make these analysts a lot more productive? And then, of course, the bread and butter is unstructured. Finally, we have a customer, like Siemens, for instance, 700,000 pages of research documents. And they're now all accessible through a chatbot. So the research team is substantially more productive. So we're seeing both of them.
You see both of them. Yeah, I think the core like knowledge-based search application blows my mind. We deployed an internal chatbot, and the summarization of large amounts of content and synthesizing in a way that's human readable, particularly for somebody who is coming into or trying to learn about a space, is absolutely phenomenal. The one feature I'm looking for is, and I don't know if this exists, but I'd be curious to hear if you've seen it, is I think about a lot of these large language models are basically averaging. They're taking a whole corpus and creating the average of the output. I'm looking for like the TF-IDF equivalent, which is, I know the core, and what I'm looking for are exceptions. I'm looking for exceptions, and like Claude Shannon had this whole thing where like information is surprise. And so large language models are really good at creating things that are not surprising because it's the average, but what are the exceptions? For us, it's customer references. We're interviewing a startup, okay? Or we're trying to understand like, why does somebody use Salesforce? Why does somebody use HubSpot? What are those exceptions? Have you seen anything like that? Does that exist within the world of large language models?
I'm seeing a lot of super interesting analysis being done very easily. So that what you're describing, for instance, can be done when you start extracting all sorts of information from documents. And then the beauty of all of this being inside a company like Snowflake is like afterwards you can then run all sorts of analysis and run SQL queries to extract specific information. So the combination of being able to work with both structured and unstructured data in a super seamless way allows you to do all sorts of deep analysis in a very fast way.
Yeah, that makes sense. And so is that where Streamlit fits in? Is that how you see customers actually using Streamlit, where you've got the data's coming in, you're running large language models on top, there's some output that's coming out, and then they're building applications on top in order to empower users? Yeah.
Yeah, you can basically build PO really easily, applications really easily with just 100 lines of code, and it's a UI that you can then deploy and use.
One question I have for you is around the world of vector databases, right? So vector databases are important. They're an important part of the stack. They store all the different encodings, which are basically all the different ways that these documents are related. Snowflake, clearly a database company, right? How do you think about the world of vector databases? Is that a world where you partner, you build? Is it important? Vector databases and Snowflake broadly written.
So we see ourselves as a platform. So we have our own solution. We also partner. Our own solution is Snowflake supports vectors. So you can both embed your text into vectors and then do vector operations on Snowflake. We also have a product called Cortex Search, which is a hybrid search engine that combines vector database with traditional text-based lexical search, so that you can do RAG very easily with high quality, combining vector and keyword-based text search, and then re-ranking afterwards. That ability to do this inside Snowflake where data is very much appreciated. And the nice thing about that is you can also use the structured data that you have for filtering and for more complex kind of joining of data. In addition, of course, we partnered with the likes of Pinecone, for instance. If our customers want to use other vector databases, that's easy to do so from Snowflake.
Yeah, that makes sense. I guess what I'm hearing, the overall theme is Snowflake is the place where the data exists for all of your customers, right? It's a place with maximum data gravity. You are building out a toolkit, a bunch of different pieces of software. You have the Cortex, where people can build a whole bunch of different kinds of applications to be more and more open models. Open source is a really big theme. You have Streamlit to build the underlying applications. There's a vector database. So the totality of all the different tools that you might need in order to either perform data analysis exists within Snowflake. And then another big push is, and we've heard this also from data leaders, there's this kind of divide within the world of data leaders about pushing out analytics to the edge. And some data leaders say, I really want to control because interpretation is really important. And then there are other data leaders who really believe in the decentralization of data and decentralization of analysis, because their view is that it's more important that a marketing manager gets access to the data and has a sense of what's going on. And the large language models like Arctic and others are in a place where they can actually get them a reasonably good, if not perfect answer very quickly.
Yeah, so we're straddling both of these desires. We have this product that we use is Cortex Analyst to do this kind of structured text to SQL to data. And in that product, we allow our customers to create what we're calling verified queries. So whenever a user asks a question that we know has been verified before, you can then have high confidence that this answer is the right answer. But then you have a lot of flexibility, and then there's a feedback loop, of course.
That makes sense. That's really important because then you can bridge this, right? Where somebody can go off on their own, but if there's a blessed query, an approved query, they can have a lot of confidence that the ultimate output of that query is validated by the data team, interpreted the right way, normalized for whatever it needs to be normalized for.
Yeah.
That's really smart. It's wonderful to hear the vision from you as at the center of AI. I think this idea, like I said before at the beginning, one of the greatest challenges I think a lot of data leaders have is around having confidence. One, that the models are working, but two, that they're operating within a trusted universe for security. And the fact that you're building all these different components into the toolkit and pushing into open source, I think really positions Snowflake well.
I hope so. I'm super excited about what we're doing. And also, it's an exciting time. So much is happening and so fast. Really looking forward to how the world is changing.
Same here. I think it's hard to keep up. There's a new research paper. There's a new model that's like pushing a benchmark. And I think the way that we'll all work with data in the future will never be the same. Thanks again for the time, Baris. This was a pleasure having you on Office Hours.
Thanks for having me. I appreciate it.
All right, bye.
Bye.